Hello everyone, welcome to yet another video on surface area and volume. Well, what is very special about today's video tutorial is the question is clear. The students know all the formula that is required for them to know about surface area and volume. But still, there is a challenge in solving this problem because they do not know which formula to implement here to get the results. So let's jump into it straight away and hope this video clarifies the question that most of you have. Okay, what is the question here? A copper wire 3 millimeters in diameter is wound about a cylinder whose length is 12 centimeters and diameter 10 centimeters. We have a cylinder. We have a cylinder something like this, and what is being mentioned here is a copper wire is wound about a cylinder. So you'll have a copper wire wound around a cylinder, right? You'll have this copper wire completely enclosing the cylinder. Cylinder अगर ऐसा है तो copper wire पूरी तरह से cylinder को घेर लेता है in circles. So effectively, if you see, this copper wire would look something like this from the front of the cylinder, and from the back of the cylinder also this wire goes, and then it would again come from here. Again it would surround the cylinder from the front, and it would be something like this. So if I just draw a continuous line, this is how the cylinder would be completely wounded by the cylinder, right? So this is the front part of the cylinder, right? So this is how it will look like. So it's completely, enclosing the cylinder. And what do we know about this cylinder? So we know one thing about the cylinder. Cylinder is 12 centimeters. The length of the cylinder is 12 centimeters. So this dimension that we have is 12 centimeters. And diameter is 10 centimeters. So we have the diameter also given here in the question is 10 centimeters. So this is also given to us, which is 10 centimeters. And the copper wire, this copper wire is 3 millimeters in diameter. So if this copper wire is completely enclosing the cylinder in circles, right? It will make many circles, right? So it will make one circle, then the second circle, third circle, fourth circle. So the first circle, the second circle, the third circle, the fourth circle, and it just goes on and on. Of course, here we are still showing some gaps here, right, in between the two circles, but actually there is no gap. That's how it is wound completely, in such a way that you can't see the cylinder. You can only see the wire from all sides. So effectively it will look something like this. The cylinder is completely surrounded by this wire. Now we know one thing, this length of the cylinder is 12 centimeters. For one circle, now this particular wire is actually 3 millimeters, right? The 3 millimeters in diameter. So effectively, if you see, 3 millimeters is one circle. It is capturing that much width of the cylinder. This is another 3 meters of the wire. This is another 3 meters of the wire. Another 3 meters. Another 3 meters. So every time the copper wire is consuming 3 millimeters from this 12 centimeters. So like this copper wire, you might have multiple circles of the copper wire to completely cover this 12 centimeters of the cylinder. The length of the cylinder, you have to completely surround it by this copper wire, 3 millimeters in diameter. So like this 3 millimeters, you might need so many circles, right? If you have 12 centimeters of this length of the cylinder, how many such rotations are required of the copper wire? We do not know. let us assume it is n rotations. So this is one rotation, this is 2, 3, 4, 5, and this just goes on and on, right? You'll have 6, and let's say you have n rotations. So each rotation, the width is 3 millimeters in diameter. So this is 3 millimeters. So if it is 3 millimeters, now since everything else is in centimeter, right? So if I just convert that into centimeter, it will be 3 by 10. So this is centimeters and this is also centimeters. So with this formula, we can find out what is the number of rotations of the copper wire. So if I just cross multiply, or 3 4s are 12. So n equal to 40. So like this, we'll be having 40 rotations of the wire to ensure that the wire completely surrounds the cylinder from all sides. There are no sides in cylinder, but yeah, it completely covers the cylinder. So the number of rotations of that wire is going to be 40. Now, in each rotation of this wire, so we talk about this rotation, we talk about this rotation, we talk about this rotation, every time it consumes, there is a certain dimension that it consumes. And what is the dimension? 2 pi r. Circumference of that one rotation is 2 pi r. 2 pi r. And what is the radius here? Radius is the radius of the cylinder. This cylinder, right? So this wire is completely surrounding the cylinder. 2 pi and radius is 5. So it is equal to 10 pi. So 10 pi. So one rotation of the wire is equal to 10 pi is the circumference or the length of that wire for one rotation. Now we have 40 rotations here. So for 40 rotations, what will be the length of the wire? 40 into 10 into pi, which is 400 pi. This will be the length of the wire. If we unwind it and we stretch it, right, and the wire looks partially like a cylinder, we already know this is 3 millimeters diameter of this particular wire. This wire is 3 millimeters in diameter. Now, once we unwind this thing, we need to find the length of this diameter, length of this wire. Let us say it is L, and this L is 400 pi, which we just calculated using this formula. So if we have to again expand this, so the length of this wire is going to be 1256 centimeters. So with this, we have found out the first part of the equation, the length. Now we have to find the second part of the question, which is we have to find the mass. And from physics and chemistry, we know the formula for mass is equal to volume into density. Okay, density, do we know? Yes, density is given to be 8.88 grams per centimeter cube. So here it is grams and centimeter cube. So let us try to find the volume also in centimeters. So volume will be, now this is a wire for which we are trying to find the volume, and this wire is cylindrical in shape, a very thin, lengthy cylinder. So it's cylindrical in shape. So the formula for finding the volume will be pi r square h. So pi is, say, let's keep it as 25, we'll do pi as it is, pi into r square. What is radius? We know the diameter is 3 millimeters. So it will be 3 by 2. that will be the radius, and it is in millimeters. So if you have to convert that to centimeter, you have to divide it by 10. So 3 by 2 into 1 by 10 the whole square into, and what is the height? Height is 1256 centimeters. So this whole thing will be centimeter cube. So if we now expand this, it will be this is going to be the volume. So equal to 3.14 into 15 square is 225, so it will be 0.0225, because 15 into 15, 0.15 into 0.15 is, there are 2 digits after the decimal, 2 digits after the decimal here. So I need to have 4 digits after the decimal. So I put a 0 and then the decimal comes here. So 0.0225 into 1256. So once I calculate this, how much will I get? Let me just see. Two decimals, it will come to 3943.84. And now I have to multiply that by 225. Whew. So I'm going to convert that to 0.023, approximating it to two numbers. The 225 gets converted to 0.023. So it comes to 90.7. In case there is any calculation mistake, I would request you to just check at your end as well. And mass is equal to, so this is 90.7 centimeter cube. So 90.7 into 8.88. 8.88. Equal to again this is how we find the mass of this particular cylinder. This is not a cylinder, this is actually a wire which is cylindrical in shape. This wire is this thin wire which has been surrounding this cylinder, right? This is the thin wire from all sides. So this is another kind of question which is asked in the examination from surface area and volume perspective, and I hope I have been able to explain this really well for you. That's all I have for you in this video. If you like what I'm doing, if you like the way I'm teaching, do subscribe and like my channel, so that as and when I upload more videos, you get an immediate update of it. And if you have any comments, suggestions or questions, please do post them in the comment section. I would love to read all your comments, so that if required, I can create more videos based on whatever questions or suggestions that you have. Alright, that's all I have in this video. Let's catch up in another video solving another problem statement. Have a great day. Bye.